Right, so for the typical examination question, it will look something like this, and in particular part 2 is the one that's a little different after applying HCF or LCM. Okay, so first one, 2250 as prime factors, I think that's pretty okay. Divide by 5. 450 divided by 5 again. 90, now I can 245, I get 5 again, get 9, 3, 3, 1. Okay, that's a bit messy, that's not so nice. Let me just change it over here. 3, 3, 1. So 2250 as a product of prime factors is 2 times 3 squared times 5 cubed. Okay, so now back to the part 2. Now you just have to be very clear on what it means by a perfect cube. Just by the word cube, it will mean power 3. Okay, so currently, or what we want is 225 multiplied by some number x, which you're going to find out. You want the ultimate value to be a perfect cube. So right now we have, based on 2250, 2 times 3 squared times 5 cubed, right? But if I want the result of this to be a perfect cube, it would mean that 2 will have to have power 3, and 3 would have to have power 3 as well. Now, if I now break it down into its two parts, currently 2250 is 2 times 3 squared times 5 cubed. Now, multiplied by what will give me 2 cubed, 3 cubed, 5 cubed. Okay, you just compare the powers. Right now, for the 2's, you have a 1. It would mean x would have to have 2 square in there to get 2 cubed. Similarly, looking at the 3's, currently 3 square, I would have to multiply by 3 more to get 3 cubed. 5 I don't need to touch because it's already 5 cubed. So therefore, we can see that x is just 2 squared times 3, and we evaluate it because they did not say to leave it as prime factors. So x is the value 12. And that is your typical kind of question. Sometimes they ask for cube, sometimes they ask for square, so on and so forth. Okay.